Lesson 13.3 is about the radian measure. By the end of this lesson, you should know what a radian is, and then you should be able to convert between radians and degrees and use that information to find the length of an arc of a circle. So to start with, we need to get some definitions down. First of all, the central angle is the angle that's created when you have the vertex of an angle centered in the center of a circle. So when you have a central angle such as this one, it cuts off a piece of the circle here, or it intercepts a part of the circle. So this edge of the circle between the initial side and the terminal side of the angle is called the intercepted arc. And that brings us to our main point, which is radian. 1 radian is the angle required to intercept an arc whose length is equal to 1 radius. So in this picture, if the radius of this circle is 6 inches, 1 radian as a central angle, theta equal to 1 radian, would be the angle required so that this intercepted arc was also 6 inches. So if the radius is equal to the arc length, then the angle must be 1 radian. So a question that would be helpful to know the answer to would be how many radians are in a circle? Because I think we all know that there are 360 degrees in a circle. So if there are 360 degrees, how many radians? If you think about the formula for the circumference of a circle, circumference equals 2 pi r, then we know how many radians are in a circle because 1 radian is the angle required to give us an arc length of 1 radius. So if the radius is r and the circumference contains 2 pi radii, then that means that there are 2 pi radians in a circle. So all the way around the circle would be 2 pi radians. If we went this, 2 pi radians. So that means if we only go halfway around the circle, that is 1 pi radians, which is equal to 180 degrees. We can use this information to convert between degrees and radians. So for example, what is the degree measure of an angle of negative 3 pi fourths radians? Well, first I'm going to draw the picture. If I know that all the way to the 180 is 1 pi radian, then that means the 90-degree mark here must be a half a pi radians. So 3/4 is halfway between right here. So this is negative 3/4 pi. And so if we want to convert that into degrees, you can probably figure it out. But one way we can do it is using dimensional analysis. With dimensional analysis, you start with your radian measure, and you use a conversion, a fence and post, to convert it into degrees. So if we know that 1 radian is equal to 180 degrees, then we can use that conversion factor. 1 pi radian equals 180 degrees. So we can cancel the pi radians because one's on top and one's on bottom. And then we just have to simplify this fraction. And this fraction simplifies to negative 135 degrees. That's the same thing that we would get if we did a calculation of 90 degrees plus 45 degrees is negative 135 degrees. So how about pi halves? So we can take pi halves radians. Using our fence and post, we can convert that. 1 pi radian is equal to 180 degrees. So we can cancel the pi radians, and that gives us 180 divided by 2, so that's 90 degrees. The same thing we had figured earlier. If we just have 2 radians, we can do the same thing. So we have 2 radians. Notice there's no pi on that. 1 pi radian is equal to 180 degrees. So the radians will cancel, but the pi's do not. So this gives us 360 degrees divided by pi, which we could calculate in the calculator, and we get 114.6 degrees. We can also convert radian measures or degree measures into radian measures doing the same thing. So if we take 27 degrees, if we want to turn that into radians, we flip our conversion factor over and we say 180 degrees is equal to 1 pi radians. In this case, the degrees will cancel, and then we just have to simplify the fraction. So 9 goes into 27 3 times. 9 goes into 180 20 times, and so this fraction simplifies to 3 pi over 20 radians. 225 degrees can be converted into radians using 180 degrees is equal to 1 pi radians. So in this case, we can simplify again, and this fraction will reduce to 5 pi fourths radians. And you could do the same thing with 150. Go ahead and try that if you would like. That'll be the end of this first video, and I'll see you in a few minutes.